Hi friends, this is from Anup Kelkar's Python Academy. So today we are going to work on one data analytics and machine learning project. For that we had taken the data set from Kaggle and the data set name is live cancer prediction. Okay, so basically data set is present in a CSV file format, that is a comma separated value. Okay, and if you see in this data set the first row, that first row is a column name, or sometimes we call it as a feature. Okay, so where the column names are given to you: country, region, population, incidence, majority. So basically in this data set the information is given about the people, those who are belong to the different nationality and the different region, and their uh, population wise data is given to you, and what are the mortality rate of that country according to gender wise. Also this data set reflect the information about whether the how many peoples are diagnosed with various disease like hepatitis, obesity, diabetes, whether they are belongs to the rural area or urban area. Okay, whether their intake is in seafood or in herbal food. So this kind of information is given to you, whether they are in alcoholic or not. Okay, whether they had a, if they are diagnosed with any liver cancer, so whether they had taken the treatment or not, or how many percent of the how many people have the chances they can be diagnosed with the liver cancer. So basically all such kind of information is provided in this data set. Okay, so as of now if you see the first second row, that is Nigeria. So this is a record for those people or individual, they are belongs to the Nigeria country, their region should be sub-Sahara, and their population of that country should be nearly 3 crore. Let's see into 100, nearly 34 crore something, and out of that, okay, so out of that they are male. So out of that, they are, what are their ethnicity? The ethnicity should be Hispanic, mixed, and African. What are their preventives? Care, whether their care should be in good state or in moderate or in poor. What are their survival rate of that person? That should be nearly 17%. Some of the people have 17%, some of the 19%, some of the 68 onwards. What are the cost of treatment? How much cost is required to take that treatment to the customer? So for that it requires nearly 47,486 or 13,782. Okay, and the last column is prediction. So prediction is a column which, while applying the machine learning, it will get the how many whether that selected person are going to diagnose with liver cancer or not, what are their predictability. If their prediction should be yes, in future or currently, if that patient are suffered from some liver cancer, so they are, or if they had taken such kind of diet or intake, so there may be a chances in future that person should be in that person should be cured or diagnosed with liver cancer. Okay, so with the help of this data set, now we will try to analyze that data set. Okay, so basically this project has been divided into two parts. So in first part we will first analyze the data set, okay, and the later on part, or maybe in second part, we will try to use the machine learning with the help of this data set. Okay, so for the today onwards, from till today, or from as of today, we are going to first analyze the data set, okay, based on such kind of information. So let's see. So for that you have to first use the Google Colab, or if you already installed Jupyter notebook, then no problem. But if you didn't install Jupyter notebook, so it is better you can go with the Google Colab, okay, that will be directly linked with your Gmail drive, okay, and you have to download this data set. As of description, I had given you data set also, okay. So let's dive into how we will analyze this data set, okay. So always, first of all, we try to import or add the library. Some libraries are required. So first library we are using NumPy, that is a numerical Python, because there may be chances in dataset some of the information should be present in numerical form. So therefore we had a use NumPy library, as an alias name is a NP. Instead of writing that complete spelling of the NumPy, so we had used an column alias, okay, that should be represented as an NP. Later on we have to perform some data manipulation technique. So for that we required import pandas as PD. PD is the basically, again, they are the alias name of that command. So once you clean or transform your data, now some uh, visualizations are required. So for that we use matplotlib visualization. Matplotlib, under that matplotlib we have using Python package, that is a pyplot. Then we have to use as a complete matplotlib.pyplot. For that we are using alias name, that is a plt. So wherever we required function related to visualization, that time we can use plot plt alias instead of write that complete matplotlib.pyplot, okay. Later on we will import some of Seaborn library. Some of the advanced visualizations are required. So for that we have to use Seaborn library, as an alias is SNS, okay. So for that we have to write, again we have to ignore the warning. So for that we have to write import warning, and under the warning we have to provide the some if warning is occur, so we have to just ignore that warning. So for that we have to write warning, some filters warning should be required, okay. So for that we have to keep as a filter warning. So filter warning should be written like that: import filter warning as an, while we have, wherever that warning should occur, so we have to ignore it, okay. So basically for that we have to write ignore. That means whenever you are running such kind of program, there may be a, it may be very, so if your system or if your software is not updated, so there may be a chances it may raise some warning. So to avoid that warning we have to write this line. We have to first import the warning pack module. Under the warning module we have to use filter warning. That means you are trying to filter your warnings. If such kind of warning is occur, so we have to ignore it, okay. That doesn't, this is the only meaning of the line. Now we move to the load of the data set. So let's see how we will load the data set, okay. So for that we have to use as in data frame. For the data frame we have to write as a short form of df pd dot read underscore CSV. So for that we have to use liver underscore cancer underscore prediction dot CSV. Now if we loaded this dataset correctly, then we have to print the data frame name. What is the data frame object? DF. So let's see whether we will get the data set or not. So they are saying PD is not written, but I have to run this line. Okay. No such file or directory. Liver cancer, LIVER, liver, CANCER. Okay, we had written wrong spelling. Okay. Prediction. Okay. So here we are getting the data set where some columns are there like mortality rate, gender, age, alcohol consumption, whether they are consuming low, they are consuming moderate amount of alcohol, they are consuming high amount of consumer, whether they are smoker or not. Such kind of data are provided to you. So if you want to view the top 5 rows, so for that we have to use the head function. With the help of head function we are getting the top 5 rows only. We are getting the data from the top 5 rows. Okay, if you use sorry. So basically while generating the data set, suppose we have to view the top 5 rows. For that we had used age head function. Under the head function, suppose if you try to find out how many columns and what are the names of columns that should be present, so for that we have to write data frame names, then columns, then enter. So basically here they are getting the list of argument as in column name, like there are total country, region, population, incidence rate, mortality rate, gender, age, alcohol consumption, and obesity. Such kind of information has been provided. Okay. So if you want to find out in that data set what are the dimensions of it, so for that we have to use df dot info. So with the help of info command it will return the how many uh, rows are present or records are present in that selected column and how many values are null. Okay, so if you see in the entire column names, there are the total non-null values are 16,292, and in all the column names of that data set there should be not count should be not null. Okay, and their data type that should be given in column name d type with respect to the column name. So basically if you see object, so object is a data type which holding the data in column country and region. So likewise all the data types are provided to you, and while applying the info command they will give the summary of the data. Okay, that will provide the summary of data. So now if you want to generate the descriptive statistic of data frame, or if you try to provide what are the quick summary of that central tendency. So for that we have to use describe command. While running this describe command, it will shows the descriptive statistic of the data frame. Okay, it will shows the descriptive statistic of the data frame. So if you see the column wise how many values in this column name population, there are total nearly 16,000. What are the mean of it? What are the minimum value of that entire selected column, that is also given. What are the standard deviation, how the values are deviated from the center. What are the minimum value of each column, what are the median value, that is a 50% of that each column. So likewise such kind of information has been provided in info command, which generates the summary of the data. Through that you can get the little bit idea about it. Okay, so uh, once you had given the summary of the data set, so now it's time to generate some descriptive statistics. So for that descriptive statistic we had used describe command. Descriptive command. Okay, so basically the descriptive command that will generate the statistic of data frame, that provide the quick summary of central tendency or dispersion or the shape. So for that now we move to the next part of it, that is a data pre-processing. Okay, so why we are using data pre-processing? So basically if you want to transform your raw data into clean and proper structured format, so for that we have to use format the suitable for training and evaluating machine learning model. So if you try to verify how many null values are given. Okay, so if you want to handle, if you want to handle the null values, so for that we have to use data frame name, that is data frame name df dot. So for that if you want to use how many columns have the different missing values, so for that we have to use df dot is null. Is null is that will return the boolean values wherever the values are blank or null. At that place while running this is null function it will return true. That means in this selected column and value or cell here the values are missing. Okay, so it will return there are total this name of the column are given to you, and all of the column have not, all of the column doesn't have not null value, that is completely not null in each of the column of the data set. By mistaken or by knowingly all the values are filled. Okay, therefore it will given 0 if the data is already filled. Okay, so later on if you want to check the outliers for that data set, so for that we had using the visualization to detect the outlier, that is box plot. Okay, so basically before moving to the box plot calculation, so let me told you what is outlier. Okay, so basically if you see outliers is a value that is learned from the data set, that significant value that should be sometime uh, as much as bigger than rest of the values of that data set, or sometime it may be significantly different from the majority of the data set. Okay, so for that, if you want to find out, if you want to find out how to find out how many values are missing, or how if you want to find out the outliers, so for the outliers we have to always use box plot. So for that, how we will use box plot? SNS dot box plot, and if you want to find out the box plot of every columns of the data set, so for that we have to put the data frame within the box plot column. Let's see, it will gives the visualization where it have the different form of majority of the data set. So if you see only the first column, that is a population that has, so for that it will be taken only one column as a name, and rest of all the column that should be aligned with the null values. Okay, if you want to check the outlier, so basically outlier is a machine learning or data point in the significantly that is different from the majority of the observation. Next one is the feature scaling. So while moving to the feature scaling, so for that, if in this, while using the, while if you want to find out how we handle null values, so for that we will use is null operation. And if we want to find out the sum of all the values of the selected column, therefore that we have to use sum function. But by mistakenly in this data set there is no as such null values are there, so therefore we doesn't use any imputation techniques like mean, median and mode. Okay, so first let me check what are the outliers are there. So for that, rest of all the column name that should be in not in a state of a box plot. Okay, so for that here we use the concept as a feature scaling. Okay, before moving to the feature scaling, let me understand and let us learn what is feature scaling. Okay, so the basically feature scaling that will transform your data into the categorical into numerical values. Okay, in the feature scaling we had using the two different types of technique. First one is a min max scaler, second one is a standardization. So if you move to the min max scaler, what it will do, it will first transform your non categorical values into categorical one. Then if you want to check out the box outliers, so for that we are use box plot is also there. Feature scaling, so under the feature scaling we have the two types of method. First one is a min max scaler and second one is a standardization. So if you move to the min max scaler, so that will scaling and transform your data in a within a fixed range that is 0 to 1. But if by mistaken or by different arguments, if we had using another technique of the feature scaling, that is standardization means basically it is a technique that is less sensitive to the outlier, and data arrived in a mean, that is the mean should be 0 and the mode that should be 1. From the now we will move to the labeling techniques. So under the labeling technique, before while using the feature learning technique, so first of all we have to use the command where from that we will try to use that algorithm of the feature scaling. So the command for that is a from sklearn, there should be in pre-processing part. After the pre-processing we had import min max scaler. So for that we have to write min max scalar. So actually it is a pre-processing technique. Okay, so if you see the min max, basically we have the two types of pre-processing technique. First one is a min max scalar. So basically it is a technique which scaling or transform the data in within a fixed range, that is 0 to 1. Another one is a standard scalar. So basically this technique is very less sensitive to the min max scalar that should be defined within an outlier, and center of the data that should be arrived or around in the mean, and mean of the data set that should be 0, or their standard deviation that should be 1. If it is lying between the 0 to 1, that time we had used standard scalar, but for a time being here we are using min max scalar. Okay, so before moving to the min max, first we have to use, while using the min max scalar we have to import the min max scalar method with the help of this uh, line. So min max scalar is a method that should be come under the pre-processing part, and for that, for using the pre-processing I have to import sklearn package or library. So for that we have to use from sklearn.preprocessing import min max scalar. So min max, if you see the initials of the min max and scalar, that should be in uppercase, or if you written min, and while writing the min, if you click on tab buttons, that will automatically suggest some of the name that should be look alike with that keyword, that is a min max scalar. Okay, so let's see how we will apply min max scalar on that data set, how we will be use pre-processing technique on the data set. So first of all we have to uh, call that method. Okay, but while calling that method, for that object is required. So for that we had using the object as a ms. Okay, so what it will do, while calling the min max scalar, fit the it will fit the target variable, and the target variable of based on our data set is population. So with the help of population we will trying to identify how many populations has been uh, diagnosed with the liver cancer, how many populations in country wise they had survived, and how many population in country wise they had lost their lives. Okay, so for that we had used uh, fit method of the min max scalar. Okay, so for that we have to first use the column name. Based on that column we were trying to use uh, the column base. So what is the column name here? uh, Population is there. Yeah, here the population column is there. You have to simply select, copy it, because sometime while writing the column name there may be a mistake, there may be a spelling mistake. Okay, so here we had tried to fit the column population. While fit that column, so now it's time to transform that data, and while transforming the data, that means we were scale down the values around the 0 to 1, where the mean should be 0 and the standard deviation that should be 1. Okay, so for that we have to use df of population that should be scaled down with the min max scalar. So object of the min max scalar that should be ms, while transforming the values of the selected column into the 0 to 1 form. For that we have to use column name. If it is transformed easily, now if you want to find out whether it is transformed or not, you can simply print that column name. Okay, so for that we have to write sorry, column name their column that should be population. Let's run it. So see, this is transformed into the numerical form, that is a categorical into numerical form. Okay, the values should be scaled down. If you try to find out what are the values of the population column, so for that you can simply print the data frame while passing the top 5 rows. So if you see in the population column, their value should be given, and before pre-processing, what is the value of that call population? Sorry, whether we will get what are the see the value of the population column, that should be in millions. Okay, and there what are the column, what are the data type of the population column? Let's see data type of the population column. If you want to find out the uh, data type of that each column of the data set, so for that we have to use df dot d types. So that will return the data type of every column. So if you see the data type of column population, that is in float form, okay? That is in decimal form. Therefore, the value should be reflected like that. Okay. So if you want to find out, if you want to check whether the data has some outlier or not, because while analyzing the data, outliers plays very key role. Okay, because if in data set, if the outlier exists, so that will create problem for why after that afterwards. Okay, so while find out the outliers, so for that we had used box plot. Okay, so box plot is the best visualization to detect the outlier. Okay, so let's see, we will try to find out the outlier with the help of box plot. Okay, sorry, it's not box and plot, it's a box plot. While passing, now we have to find out the data frame name under the box plot. So it will gives the outlier with, or it will indicate whether which of the column has contained outlier. Now let's see, it will return some visualization as in box plot manner. So if you see, these are the some values which has contained some outliers like population, incidence rate, fertility rate, age, survival rate. Okay, so now to handle this box plot, we had required one technique as in min max scaler. Okay, now we have to scale down all these 5 columns. So for that we had used min max scaler, as in min max scaler. While calling this function, okay, initially if you want to print this value, so see what it will give. It will use, means your min max scalar is called easily. Now we will try to transform the values of all the column where the outliers are exist. So exactly what is outlier? Outlier is basically a value that is uh, very small from the rest of all the values of the data set, or that is very large from the rest of all the values. Such kind of values we put in the category of outliers. Okay, so we have to transform the values of this column. Basically 5 columns are there. The column's name is incidence rate, mortality rate, survival rate. Okay, sometime age is also there. So now we have to transform it. So we can write df of, so for to minimize, to transform that, for that we had used ms is the object of the min max scalar. Okay, so for that we can use, while using the fit method, we were trying to scale down the values of that selected column. So for that, sorry, fit transform is there. Df of, now we have to pass the column name, that is incidence. Let's see, what is the column name. Yeah, this one. Incidence rate. After that we had used another column, that is mortality rate. After that we have to provide another column name, because that also exist, that there, and that column also outliers exist, that is age, sorry, it's age. After that we have another column, that is survival rate. Survival rate. So basically these are the column name. If you want to change the values in the existing data set after transforming the data of that value of that selected column, so for that we have to assign this line with the, while subsetting this column. So for that we have to write here, uh, let's run it. Now it's, now if you want to see, this line is executed correctly. Okay, but if you want to find out whether that data is transformed or not, okay, so for that again you have to use box plot with the help of such kind of uh, sorry, box plot with the help of data frame. So for that again you have to use sns dot box plot, now df. Now let's run this one. Yeah, here also mm, we had minimize, we had said, we had tried to transform it, whether they we had, yes, we had transformed it. Okay, if you want to see the values of the selected column, so you can simply print this line. You will get the value of that selected column. So this is the value which is transformed. Okay, okay, so if you now, to see the how this value has been transformed, so for that we had used one visualization, that is the hist plot. Okay, while calling the hist plot we can pass this uh, subset of this column. So for that we had used sns dot hist plot. Within the hist plot we have to pass this value. Now see that will, this line has been created hist plot or histogram, that will suggest the how the data has been varied. So if you see here, this is a legend. Okay, we had created a histogram or hist plot on selected this four rows, four columns: incident rate, mortality rate, age, and survival rate. So if you see here where the orange color is lies, that is a mortality rate. Okay, that should be lies in between 60% of the people has been mortal. There are total nearly 1800 to 1900 peoples are there. They has been survived. Sorry, they has been died due to the liver cancer. Okay, but if you see the age, so age wise, total the 60% of the people has been survived. They are belongs to the specific age. Okay, so likewise we had created the his plot, and so here we had analyzed our data set. Okay, so basically in today we had seen how to clean the data set. Okay, with the help of different techniques. How if the data is not in form of proper values, so for that we had tried to scale down with the help of different method, that is min max scaler. Sometimes we had also used standardization technique, also normalization is also okay. So that will convert the categorical values into the numerical value. Okay, that is a transformation technique. While analyzing the data, it is very important, you have to first verify whether the data contains some outliers or not. So for that, to detect an outlier, see, while detecting the outlier in dataset, we have different techniques. Some of the techniques are interquartile range is also there. Okay, z square is also there. Sometimes we call it as a g score. Or in visualization form, if you want to find out how many values are outliers, so for that we had used box plot visualization. Okay, so from today we had tried to analyze the data set. We had performing feature scaling. Okay, how to check the outliers for the selected data set. Okay, how to handle the null values. So today we had covered such part, and in the this is the part 1 for the for this data set. Okay, therefore I had given the name of this file as in liver cancer prediction ml part 1. Okay, the next week we will cover the second part, which is the last part of this project. Okay, so till now you have to practice this data set and revise all the concept which we had used in this uh, project or in this data set, like feature scaling, what is a feature scaling, what is pre-processing technique. Okay, we have to verify it. So till now you have to practice on this concept. And the last part of this data set, that is a now in the second part we will cover ml part. Okay, so till now we had tried to analyze the data set. Okay, in the second part we will use machine learning techniques, and in machine learning we will try to mostly split the data set into train and test. After that we will try to create a model based on selected algorithm. Once you train and test your data, then we will evaluate it based on the different evaluation techniques are there. Okay, and afterwards the last part of the ml project is we are trying to create a classification report. Okay, so this part has been ml, all the ml part has been covered in the next week based on same data set. Okay, so as of now we were trying to analyze the data set. Okay, if you have any query regarding this data set or an analysis of this data set, so feel free to ask in comment section. Okay, so as of now, bye, thank you, have a nice day.